In the first example, we looked at a bunch of set of ordered pairs, but relations can also be modeled in different forms. As you can see, this is a little XY chart here, where you can see the x's are paired with the y's. So this would represent 1, 5, 2, 6, 3, 7, 4, 8. And this is called mapping. So here, this is your x values, your x's, and these are your y's. Yeah, so 1 is paired with 5, so 1, 5, 2, 5, 3, 7, and 4, 7. So now what we're going to do is we're basically determine what makes something a function again based on your relation. So again, it's the same concept that I wrote before. The x's cannot repeat. So in something like this, you could not see an x used multiple times on this side. And then over here, as you can see, it does not matter if the x's go to the same y value. It only matters if the x's go to more than one y value. So right now, this is actually a function. But if I were to come in here and do this, and say 4 is paired with 7, but 4 is also paired with 8, then that would make it not a relation, or not a function rather. So the x's cannot be paired with multiple y values. And what you need to know also is the x's can be listed as different things. X's can also be referred to as your domain, your input, or your independent variable, where your y's are often called your range, your output, or your dependent variables. Now, one thing that you need to know that's very important to us is that y is equal to f of x. Those two things are interchangeable. So also down here on this list for y's, I'll put f of x. So hopefully that helps in determining whether a relation represents a function in different ways. Obviously, if you have a graph, you can use different methods also.